Children, welcome to our tuition classes. We are doing geometric revision series of 2-mark questions. We are on lecture number 4, question number 23. Okay, a washing tub is in the shape of a fulcrum of a cone, has a height 21 centimeter. The radius of the circular top and the bottom are 20 centimeter and 15 centimeter respectively. Find the capacity of tub in liters. A washing tub is in the shape of a frustum of a cone. I hope people understand. What is a frustum of a cone, children? I'll just draw it for you. Just a rough figure. You can see it here. This is a frustum of a cone. Okay, you can see here, children. This is a frustum of a cone. I hope people can see. Okay, a washing tub is in the shape of a frustum of a cone. As a height 21 centimeter. The height of this is 21 centimeter. As a height 21 centimeter. Okay, the radius of the circular top and the bottom, like R1 is 20 centimeter and R2 is 15 centimeter. These are the radii of the top and the bottom. Radii of the top and the bottom. And the question is, find the capacity of tub in liters. How much water it can hold, okay? How much water it can hold in liters they want, okay, children? So how we go about, children? Please have a look here. I'll just say simple. For the, I just drawn it here. I'm going to rewrite for the tub in the form, in the shape of frustum. You can see here, children, for a tub in the shape of the frustum. You can see this very clearly, children. We just write. My way of writing is always like this. About which solid figure we start, I'll always say for the solid figure, okay? For the tub in the shape of a frustum, okay? What is given? The height of the tub is 21 centimeter. R1, okay, the radius of top, which is biggest radius, is how much, children? 21 centimeter, okay? And the radius of the R2, radius of the base, bottom, radius of the bottom is 15 centimeter. Okay, now what I'll do, children, they said use the word capacity. Whenever you find the volume in terms of liters, we usually call it as capacity. Okay, capacity of tub. Capacity always we find it in liters. But as such, volume in terms of meter cube or centimeter cube. Here it's in units are centimeter. So naturally, volume, I'm going to get it in centimeter cube. The volume of the tub equal what it will be, children? 1/3 pi, okay? R1 square plus R1 R2 plus R2 square into H, okay? Now, what is this going to be, children? 1/3. They're not given us a value of pi. I'm going to take the value of pi as 22/7, okay? And what is the value of R1? R1 is 21 square, children. And what is this? 21 into R1 into R2. 21 into 15 plus, what is this? R2 square, 15 square. Okay, and into, what is this, children? Into H is 21. Okay, so you can clearly see 7 ones are 7 threes. This 3 ones are, this 3 gets cancelled. So what you're left with, 22 into whatever things inside the bracket. This is 441 plus 15, 315, 15 plus, this is 225, okay? Sorry, 315, I have not written it in proper way. I hope people can see this, okay? This is 315, 315. So when you add everything, children, 22 into 5 plus 5, 10, 10 plus 1, 11, 3 plus 1, 4, 4 plus 4, 8, 2 plus 3, 5, 5 plus 4, 9, 81. Got it? This money, please have a look at this money, centimeter cube. Okay, if you want, you can multiply them and also write the answer, children. Like 981 multiplied by 22. 2 ones are 2, 2 8 are 16, 2 9 18, 19. Okay, again 2, 6, 9, 1. And 2, 8, 15, 11, 2. Okay, so when I multiply this, I get 21582 centimeter cube, centimeter cube. But I want the answer in liters, children. So this is actually basically, therefore, capacity of the tub will be always either, I can write it as 21582. 1 centimeter cube is 1 milliliter. 1 centimeter cube is always 1 milliliter. Milli matlab 1 upon 1000. Okay. So what will happen here? This milli, I want liters. So 21,582 divided by 1000. When I divide by 1000, it becomes converted into liters. The capacity of the tub is 21.582 liters. Okay. Capacity of tub is 21.582 liters. Not a difficult sum, children. Simple sum. Okay, only thing you should be able to play with these numbers. You should know multiplication. Okay, if you are good in multiplication, if you're good in adding, this chapter will look very simple, especially this mensuration chapter. Okay, surface area volume chapter will look very simple. And those who are very lazy in multiplication, lazy in adding, will find this chapter difficult. But this chapter is worth doing it, children. Easy chapter. Okay. I'll go to the next question, question number 24, children. Now, question number 24. Number 24, children, nobody will forget, There are 3 parallel lines given. Children, they're given in the question, They're given this line AB, please here. This line AB is parallel to line CD, parallel to line EF. They're given 3 parallel lines. Are you getting me, children? They're given this 3 lines are parallel. It's given to you. So whenever you see 3 parallel lines, only one theorem should come to your mind. That is property of intercepts made by 3 parallel lines. So line AB is parallel to line CD, parallel to line EF is given. And you can see the 2 transversals, line on transversal, therefore, on transversals BE and AF, this B and AF are the transversal, on transversal B and AF, BD upon D equal AC upon CE, I say by property of intercept, property of intercepts made by 3 parallel lines, made by 3 parallel lines, made by 3 parallel lines. Okay, just put the values, children. 8 upon 4 equal 12 upon 6. Now 12 upon x, sorry, 12 upon x. I want the value of x, children. So this x should be 8x equal 4 into 12, children. And now this 8 will come down 4 into 12 upon 8 for 1 time, for 2 times, to 1 time, to 6 times. So x is equal to 6 units. Very simple one. I hope people could understand this. Okay, we go to the next one, children. This is question number 25, children. In the new syllabus, this theorem, what we say about I written here, property of intercepts made by 3 parallel lines is very correct, children. This is what we are writing in the old books, okay? But now they are saying by property of 3 parallel lines, by property of what your book is giving, okay? By property of three parallel lines. Okay, this sounds easier. By property of three parallel lines and their transversals Let us change, okay? And yeah, we go to the question number 25. A very simple question, children. You can see it here. You have to prove triangle ABC is similar triangle EDC. You have to prove triangle ABC is similar triangle EDC. The question is very simple, children. So naturally, prove that ka proof hota hai, okay? Now we start in triangle ABC. Please have a look at this triangle ABC and triangle EDC. Always the way they are given the names. This names itself is one-to-one correspondence, ABC and EDC. Okay, you can see here, children, this angle ABC, that is angle ABC is 46 degree. Your D is 46, that is EDC is 46. So angle ABC, congruent angle EDC, I'll say each is 46 degree. Each is 46 degree. Okay. Then you can see here, children, one angle C is a common angle. Like angle ACB, if I name it as ACB, this will become ECD, okay? And this is nothing but common angle, angle C, congruent angle C actually it is. Okay, so now I can say therefore triangle ABC is similar to triangle EDC. The reason is by AA test of similarity, okay? So you can see here, children, this 25. Okay, question number 25. We go to question number 26 now. We go to question number 26, children. Question number 26, children. Prove that angles inscribed in a semicircular arc are congruent. Angle inscribed in a semicircular arc. Singular was right, children. Angles, prove that angle, only angle, singular angle, inscribed in a semicircular arc is a right angle. Prove that angle inscribed in a semicircular arc is a right angle. ऐसा क्वेश्चन को क्या बोलते हैं? राइडर फॉर्म. राइडर फॉर्म में आएगा तो मुझे ड्रॉ करना पड़ेगा, गिवन लिखना पड़ेगा, प्रूव दैट लिखना पड़ेगा. एक याद रखो हमेशा ये क्वेश्चन में एक वर्ड है ईज, सिंगुलर है करके ईज आ रहा है. ईज का पहला जो है गिवन है एंगल इंस्क्राइब्ड इन अ सेमी सर्कुलर आर्क. दैट मींस इस सर्कल एक ड्रॉ कर लेता हूं, एक सर्कल, लेकिन ये सर्कल हो गया, लेकिन मुझे तो एंगल इंस्क्राइब्ड इन अ सेमी सर्कुलर आर्क मांगता है. Yeah, if you draw a diameter of a circle, children, if you draw a diameter of a circle, you get the semicircular arc. Listen, you get the semicircular arc. This is the diameter. Suppose this is the diameter. Then above the diameter, you have a semicircular arc. Below the diameter, you have a semicircular arc. Now remember what they say, angle inscribed in a semicircular arc. Angle contained in a semicircular arc. So you can see here, this angle is contained in a semicircular arc. I can see this angle, like, this angle ABC. You can see here, children, this angle ABC is contained in a semicircular arc, inscribed in a semicircular arc. So given, I'll just say angle ABC is inscribed in a semicircular arc ABC. Arc ABC. And you have to prove that this angle ABC is 90 degree. Angle ABC is inscribed in semicircular arc ABC, and you have to prove this angle ABC is 90. Now, how can I prove this angle ABC is 90? So I have told you, children, whenever you see an inscribed angle, you have to use inscribed angle theorem. So this angle, if in this arc is x here, if I put x here, this arc becomes the x. Just have a look at angle ABC. Don't agree it's an inscribed angle? Whenever you see an inscribed angle, use inscribed angle theorem. Measure of an inscribed angle is half the measure of its intercepted arc. So measure angle ABC equal half measure arc AXC. ABC का inscribed in angle ABC is inscribed angle है, का intercepted arc AXC है. So angle ABC is half arc AXC. by inscribed angle theorem. By inscribed angle theorem. अगर ये आपका स्टेटमेंट नंबर 1 है, ओके, अभी देखना, बट मेजर आर्क AXC, measure arc AXC is equal to 180 degrees. ये आपका statement number 2 है. Actually, measure of a semicircle is 180 degree. Measure of a semicircle is 180 degree. Measure of a semicircle is 180 degrees. So what will happen, children? Therefore, angle ABC equal half into 180. The reason is from 1 and 2. So angle ABC equal 90 degrees. So you can see here angle inscribed. Therefore, angle inscribed in a semicircular arc is a right angle. I hope everybody understood this theorem, children. Very simple, children. It can be asked for 2 marks, okay? We go to the next question, question number 27. Quadrilateral PQRS is a cyclic quadrilateral. This question number 27. No? Quadrilateral PQRS is a cyclic quadrilateral. Q dash R dash T. Q dash R dash T. And then angle QPS, measure of angle QPS is 110 degrees. And angle QRS is X. Angle SRT is Y. They wanted to find X and Y. Such a simple sum, children. You can see here, children, quadrilateral PQRS is a cyclic quadrilateral. I better write it like this first. Now, why did I write? Because if it is a cyclic quadrilateral, then I can always use a property opposite angles of cyclic quadrilateral are supplementary. Therefore, angle QPS plus angle QRS is equal to 180 degree. Reason you can write opposite angles of cyclic quadrilateral are supplementary. Opposite angles of cyclic quadrilateral are supplementary. Opposite angles of cyclic quadrilateral are supplementary. So now what will happen, children? This angle, please have a look here. QPS is 110 degrees and QRS is X equal 180 degrees. You can write it here since angle QPS is 110 degrees. That's why you put in place of QPS 110 and angle QRS is equal to X degrees because that is why they put QRS as X. Now X is equal to 180 degree minus 110 degrees. So what is X is equal to 70 degrees, okay? Now this is X, X is 70, one answer we got. Now the other one is Y. I think the easiest, SRT and SRQ. This angle SRT plus angle QRS is equal to 180 degree. I'll say angles in a linear pair. Angles in a linear pair. So SRT is Y and this is 70 is equal to 180 degrees, okay? Since angle SRT is Y and angle QRS it was nothing but X equal 70. So naturally, what will happen, children? Y equal 180 degree minus 70 degree, Y equal 110 degree. Of course, the easier one would have been like this. If we have learned the property, extra angle of a cyclic quadrilateral is congruent to interior opposite angle. SRT equal QPS, so SRT Y equal 110. Directly could have written that. Okay, that would have been much easier. We move on to question number 28, sorry. We move on to question number. Triangle element, similar triangle RHT. What is given? Triangle element is similar triangle RHT. Triangle element, similar triangle RHT is given to you. Now remember, children, when the triangles are similar, the corresponding sides are in proportion. LM upon RS equal MN upon ST equal ln upon RT. Reason corresponding sides of similar triangles. Corresponding sides of similar triangles are in proportion. So what will happen, children? ln. How much is ln, children? You can see a 3. How much is rs? Rs is not given, children. mn. How much is mn? 4. How much is st? 12. And this ln and rt both are not given. Forget it. Now rs I want, so cross multiply. 3 into 12. 4 into rs. 3 into 12. The 4 comes down is equal to rs. 4 3 times. So what is rs equal? 9 units. Rs equal 9 units. Okay. Now, I come to question number 29. A very simple sum. 28 was, children. But 29. Question says, prove that congruent arcs of congruent circles of a circle. Congruent arcs of a circle. One circle. Congruent arcs of a circle have their corresponding chords congruent. मतलब प्लीज अब लिखिए मैंने बताया बेटा जब भी एक क्वेश्चन राइडर फॉर्म में रहेगा आपको ड्रॉ करना पड़ेगा पिक्चर तो कॉन्ग्रुएंट आर्क्स ऑफ अ सर्कल मतलब एक ही सर्कल ड्रॉ करना पड़ेगा ऑफ अ सर्कल मतलब एक ही सर्कल ड्रॉ करना पड़ेगा कॉन्ग्रुएंट आर्क्स इसका मतलब है ये आर्क जो है प्लीज हैव अ लुक एट दिस आर्क is this arc, suppose red color arc. This arc is congruent to the green color arc. The red arc is congruent to green arc, okay? This red arc and green arcs are congruent. Then, please have a look here. What the theorem says is, this green arc, please have a look here. Aram se dekho. Prove that congruent arcs of a circle. Matlab, you have congruent arcs of a circle. Got it? These arcs are congruent. So, given, I just say, inner circle with center O. Inner circle. This is my given information. What is given, children? Right. Please have a look at this picture. What you talk. Picture what is that? Okay. We should know that we talk about. What picture mein kya diya? Given a circle with center O. Circle with center O. Now they said congruent arcs. मतलब congruent arcs दिया है. RKB is congruent to arc CD. The red arc is congruent to the green arc. And what did you prove? Then the corresponding chords are congruent. Arc AB का chord AB हो गया. Arc CD का chord CD हो गया. You have to prove this arc, this chords, prove that this chord AB congruent chord CD. Chord AB congruent chord CD. Chord AB congruent chord CD. I hope people understand the question. Prove that congruent arcs of a circle. मतलब एक circle है उसमें congruent arcs है. We have to prove that congruent arcs of a circle have their chords congruent. Chord AB congruent chord CD. Okay, children. Now you can see here, children. Circle with center O. Okay, center O is the center. Then they're giving RKB is congruent to arc CD. RKB is congruent to arc CD. And I want to prove the chord AB congruent chord CD. That is a question. Prove that congruent arcs of a circle have their corresponding chords congruent. मतलब these are congruent arcs and उनका corresponding chords दिख रहा है AB और CD. आपको corresponding chords को congruent prove करना है. Now listen here, children. Geometry. You learn, children, in 9th standard. Got it. What is chord? Chord is nothing but a segment. Chord AB is nothing but a segment AB. Chord CD is nothing but a segment CD. Now, whenever you want to prove two segments congruent, you try to look for triangles. Like segment AB should be a side of a triangle. Segment CD should be a side of a triangle. आपको जब भी दो सेगमेंट्स को प्रूव करना है कॉन्ग्रुएंट, आप ट्रायंगल ढूंढेंगे। ऐसा सीखा है आपको 9 स्टैंड में कि सेगमेंट ए बी कौन सा ट्रायंगल का साइड है, सेगमेंट सी डी कौन सा ट्रायंगल का साइड है। फिर वो ट्रायंगल्स को आप प्रूव करेंगे कॉन्ग्रुएंट, ताकि आपका सेगमेंट ए बी और सी डी कॉन्ग्रुएंट हो सी एस सी टी। तो लेकिन अभी कौन सा ट्रायंगल्स है ही नहीं, तो आई कैन गेट दिस ट्रायंगल्स लाइक you can see here, I draw OA, OB, OC, and OD. This constructed dotted lines, okay? So what is construction, children? Construction, draw segment OA, segment OB, segment OC, and segment OD. Draw segment OA, segment OB, segment OC, and segment OD. Now look at these two triangles, children. You know, I can say OA is congruent to OC, radius of same circle. OB is congruent to OD, radius of same circle. But one information is missing. We require 3 information for proving two triangles congruent. ये ट्रायंगल AOB और ट्रायंगल COD को प्रूव करना है कॉन्ग्रुएंट। आप देख सकते हो OA कॉन्ग्रुएंट OC है, ओके, OA कॉन्ग्रुएंट OC है, और वैसे ही बेटा आपका OB कॉन्ग्रुएंट OD है, ओके, OB कॉन्ग्रुएंट OD है, लेकिन थर्ड इंफॉर्मेशन इज मिसिंग। 3 इंफॉर्मेशन, आपको 3 इंफॉर्मेशन चाहिए ट्रायंगल्स को कॉन्ग्रुएंट प्रूव करने के लिए। तो आप बराबर देखेंगे, हमेशा मैंने सिखाया ऐसा, गिवन इंफॉर्मेशन इज अ हिंट। ये आर के बी कॉन्ग्रुएंट आर्क सी डी क्यों दिया है? तो ये आर के बी आप देख सकते हो माइनर आर्क है, आर्क सी डी क्या है? माइनर आर्क है। माइनर आर्क के बारे में आपको क्या मालूम है? मेजर ऑफ अ माइनर आर्क इज ऑलवेज इक्वल टू मेजर ऑफ इट्स करेस्पॉन्डिंग सेंट्रल एंगल। So simple, children. What you can see here, I get the missing information easily. How? You can see measure of AB equal angle AOB. Measure of CD equal angle COD. By definition of measure of minor arc. But arc AB equal arc CD is given. So AOB equal COD. Angle AOB equal angle COD I'll get. You can see, I'll show it to you once again. See, measure arc AB is equal to angle AOB. I call this as statement number 1. Measure arc CD is equal to angle COD. I call this as statement number 2. दोनों का reason by definition of measure of minor arc, by definition of measure of minor arc, by definition of measure of minor arc. Okay, but measure arc AB is equal to measure arc CD. Statement number 3 given. Therefore, angle AOB equal angle COD from 1, 2, and 3. Now you can look at both the triangles, children. In triangle AOB and triangle COD. In triangle AOB and triangle COD, segment OA is congruent to segment OC, radius of same circle. Your angle AOB is congruent to angle COD. Can I say from statement number 4, I numbered it as 4, I missed it out, I numbered it as 4, AOB equals COD. So AOB congruent COD, I can always say. Then segment OB, congruent segment OB, segment OB congruent segment OD, radii of same arc, radii of same circle. So can I say triangle AOB congruent triangle COD by SAS test? Now, when two triangles are congruent, the corresponding sides are congruent. So AB will be congruent to CD, segment AB congruent segment CD, CSCT. Got it? This is nothing but your chord AB congruent chord CD. That is nothing but chord AB congruent chord CD. We got it, children. A very simple proof. Now I go to the next sum, children. Question number 30th. Just this question number 30th is the easiest of the lot. You can see in this triangle ABC, they're giving us DE is parallel to BC. दिया है उन्होंने DE parallel BC. AD कितना है 1.8, DB कितना है 1.5.4. AE is what we want to find, question mark, okay? और EC 1.2. एकदम easy question है बेटा. जब भी कोई triangle में a line is parallel to one side, intersects the two sides, then it divides the two sides in equal ratio. That is what the basic proportionality theorem says. So how it will become, children? You can see here in triangle ABC. Can you see this triangle ABC? I'll say segment DE is parallel to segment BC. The reason is given. So segment D parallel segment BC given. Therefore, AD upon DB is equal to AE upon EC by basic proportionality theorem. By basic proportionality theorem. Now, when I substitute the values, children, AD is how much? 1.8. What is DE, children? 5.4. What is AE, children? We don't know. What is EC? 1.2. Now, so simple, children. I want this A. A will remain 1.8 into 1.2 upon 5.4 is equal to A. Here in the numerator, there are 2 digits after decimal. So I want to shift this decimal to the right. So naturally, this will become 18, this will become 12, but नीचे 100 आ जाएगा. And 5.4 में से एक decimal to the right I want to shift 54, so 10 on top. Now do all the cancellations. Yes, 10 ones are 10 times, 18 1 times, 18 3 times, 3 1 time, 3 4 times. So AE equal 4 upon 10. This is nothing but 0.4 units. Okay. So I think with this, some first study in the fourth, in the first 4 lectures, I covered some 30 sums. Again, one more lecture will be there in which I'll cover another 10 sums. With that, I'll end this revision series of 2 marks and we'll start with the revision series of 3 mark sums. Okay, children? Anyhow, see you all. Bye. Goodbye. Good night.